Hey guys, and welcome to Functional Print Friday, and welcome back to my shop. Last couple weeks we were down in my basement working on the fume pickup for the back of the H2 series Bamboo Lab printer, and it feels nice to be back in the shop. It is so much quieter out here and much better lighting. I got something to show you guys. It is over there. So about a year ago, right here on the channel, we designed and 3D printed this enclosure for my 30-watt monport fiber laser. And this enclosure has worked out really great. We finished it out with lights inside so you can see what we're setting up on the engraving bed. It's got fume extraction, and all the parts for this are 3D printed with the exception of the side panels, which are just cheap corrugated sign material. Now what you guys don't know is that this 30-watt monport is not the only fiber laser I have. In fact, someone actually reached out to me a couple of weeks ago when we did the CNC video and asked what happened to the enclosure for the fiber laser. Well, what happened to it is it doesn't exist yet. This is actually a completely different fiber laser. This is a 100-watt fiber laser from Monport. And I want to give a quick shout out to Monport for their patience. They reached out and asked if I would be interested in having one of their 100-watt fiber lasers here in the shop to use in projects on the channel. No strings attached. And I said, sure, send one out. But I'm not going to use it in any projects until I have the opportunity to design a safety enclosure for it, because I'm not a fan of using these fiber lasers or really any lasers unenclosed. It's too dangerous. Even if you have your glasses on, somebody else might walk into the shop. It's just not a good idea. They should always be operated in a safety enclosure like the one that we built for the 30-watt. They said, sure, and they sent it out. It was 6 months ago. I've just been really busy with other projects and have not had the opportunity to actually design and build an enclosure for this. And I want to get started on that today. And I think the biggest challenge that we're going to have in designing the enclosure for this laser versus the 30-watt is, again, this is 100 watts. And 100 watts is quite a bit of power in a fiber laser. Now, I understand in comparison to like an industrial fiber laser that's probably, a kilowatt or maybe even multiple kilowatts, that this is still a much lower power machine. But make no mistake, 100 watts on a fiber laser is a good bit of power. This steel is almost 2 millimeters thick, and I was able to punch clear through it with this machine. I did do some just basic testing with it when I got it to ensure that everything worked and the lens was good on it. So when we designed the last enclosure, a lot of people suggested using extruded rail like this for the frame itself. And I actually have a bunch of this left over from another project. And I think at least these 8 here, longer ones, will probably be long enough for this. I don't know that we're going to be able to use these shorter 4 ones, but I can certainly order more of these. And I found a laser safety window on eBay that is the correct rating. And I didn't just trust the rating that they said it was. I actually test fired the laser at this with a sensitive surface underneath of it, and this absorbed all the energy of the laser. So we should be good on a safety window. And in fact, it looks like this because I've got it wrapped up in saran wrap to try and keep it from getting damaged. And this is much bigger than the window on the other enclosure. So we should have, honestly, it's probably too tall. I don't know if you guys can get a perspective of that. So we might cut this into some smaller pieces and maybe even have, I don't know, more than one window. This is the material that we used for the other enclosure. This is just a thin corrugated material. This is what gets used in sign making. I think we need to go beefier than this for this enclosure. It's not just the frame itself that I'm concerned about. In fact, actually, I think the 3D printed frame parts would probably be sufficient. I think even a 100-watt laser is going to take some time to burn through that, because whatever we design, it's not that the laser would never be able to penetrate it if something went horribly wrong. You should just have enough time to recognize that something is going wrong and stop the machine before anyone is in danger. I think it would punch through this almost immediately. But I still want to use this stuff for the actual frame because I think that was a good idea. And a lot of people did say, hey, it's going to take a lot of time to print those side sections if you only have one 3D printer, which is fair. I've also got some hardware here from that other project. These are the end pieces that join these guys. I think I have enough of these, and I believe this is the correct screws for this. And I ordered another set of the under cabinet lights that we adapted for the inside of the last enclosure. So I've got those all ready to go. So I think the biggest challenge that leaves us with is what do we use instead of this stuff? And I do have a couple ideas. I think there is a material similar to this that is like a corrugated plastic material with like a thin aluminum skin on either side, or like a solid lightweight material with a thin aluminum skin. And I think that might be the right fit for this project. I believe it's also commonly used in sign making. And I think with an aluminum skin on it, particularly if it is separated by another material in the middle, should give us enough protection for the 100-watt machine. Again, we're not trying to design something that would prevent the laser from ever reaching outside the bounds of the enclosure. I mean, it shouldn't be used unattended, but it shouldn't be able to punch through it within a matter of a couple of seconds. So the longest of these rails, there is 4 at 760. I have another 4 at 680. And the shortest ones are, looks like 430. I think these ones that are 430 are probably going to be too short. Yeah, so the narrowest section would be the width. And I guess it technically fits, but there's only like an inch on either side. And you can see from a depth perspective, we need way deeper than that, and we certainly need taller in the Z. This machine is actually quite a bit bigger than the other machine. It is deeper in this direction, and it also sits up quite a bit higher in the base. And the top section, I believe, is the same size, but because the base is taller, that means the overall design needs to be taller as well. So I think I'm probably going to need 4 additional pieces in a longer length, but I want to see if I can design an enclosure that utilizes the other 8 pieces. I want to use that laser safety window that I already have. So I'm going to get some better measurements of these, and I'm going to start drawing, and I'll bring you guys back. And welcome back. A couple seconds for you guys, quite a bit longer for me, but I think I have got a design for this that is going to work. Everything should fit together, and we'll be able to reuse a lot of what I already have. So we had 4 of those 2020 sections that were 760 and 4 of them that were 680. The ones that were either, I think, 420 or 430, they're just too short. There's really no way to use those. So I'll order 4 new pieces that are 680 or longer, and we'll just cut those down to the 680 for the width. I also imported the design of the last enclosure that we designed. And I did that partly for a comparison of size, just because I kind of already know what the size of this one already looks like in the real world, but also because I figured I'd be able to reuse a lot of the design work that we did in this one, because there's still going to be 3D printed parts in this new enclosure. It's just the frame itself is going to be that 2020 extruded rail, and these solid panels are going to be a much more substantial material, but I'm fine using 3D printed parts for the outer frame of the door, the inner frame of the door, the vents here in the front. We can actually reuse the pass-through for the exhaust and the pass-through for the cords in the back as is. I didn't have to make any changes to those at all. We did originally a side exit on the old enclosure. We're going to do a rear exit on this one right from the start. And like I said, the slider here, this double door for where the cords are going to pass through, we can reuse that exactly as is. I did adjust the depth of it. I think, if I recall, the corrugated panel over here is either like 3 or 4 millimeters thick. The panels for this are going to be 6 millimeters thick, and that aligns with the space that we have in the 2020 rail here for something to slide in. We could use a thinner material there, but I think sticking at 6, this thing should be nice and stiff, and the panels aren't going to move around inside those channels. For the doors, I did have to make some design adjustments. I couldn't just sort of copy and paste the geometry and or just resize it to accommodate our larger window. This one being designed in a thinner coroplast material, that corrugated material that the signs are made from. We did like an inner and an outer. So there's the 3 pieces out here that you can see, the upper, the lower, and then the inner frame of the door. And then on the inside, there was all these pieces that sort of went around the perimeter of that. Screws went in from here, and we basically sandwiched that coroplast in between all these rigid materials. And it works great, and it's held up really well. I don't think we have to do that for this thicker, more rigid material that I want to use for this enclosure. I think, it's not pictured here, but I think we can pre-drill some holes in this material and have the screws go in from this side and then screw right into our parts that we'll either do in ETG or PLA that'll fit in from the front. Obviously the size is different as well, and in fact this one, when I designed the inner part of this door, I think I sized it to be the largest I could print in one piece, which would have been on that Neptune 4 Max. Now that we've got that Soval SV08 Max printer, we can do the longest dimension for this door at 500 millimeters. That printer does 500 by 500 by 500, so yeah, we can do, so this edge up here down to this edge down here is right at 500 millimeters. Now that's the inner door frame. That means the outer door frame is still going to have to be printed as 2 separate pieces, but you know, again, I think that's going to be fine. I didn't have any issues with doing this one as two separate pieces. Notice there's no vent down here. The vents are on the side. That's because this vent, it doubled as access to the buttons. I don't want to do that here again. What I'm hoping is with the door this far down, that when the door is open, with this unit slid back a little bit because we have more depth here than we need, I should just be able to reach through and operate those buttons if I need to. The buttons that you're more commonly pushing are the ones that are in this part of the panel up here, and those should be real easy to access. So hopefully I don't regret that. But yeah, I don't really want to have a big gaping hole through the front of the enclosure again like I did on this one. I designed these vents to go on the side. The weird angle here, what I was trying to do is just avoid a situation. So imagine the laser head is kind of up here. So I tried to design them that there's no way that the laser light could make it directly through these slats. Like there's no angle you could be at where that light has a single path through these vents, regardless of what silly angle you're at, sitting at this guy or standing, that the light at a minimum would have to bounce at least once to get through here. And once it has bounced once, between the fact that it's going to be defocused and it's bouncing off something, the wattage of the light or the power of that laser light shouldn't be enough to do harm. Now, I still recommend wearing laser safety glasses even on an enclosed machine. You know, I kind of think the belt and suspenders approach to safety for something that can make you blind almost instantly is probably worth it, but you know, that's a decision that everyone gets to make. I see plenty of people operate these machines without even an enclosure, which I think is crazy, but hey, you get to make your own choices with regard to safety, at least in your home. So knowing that we're limited to 500 millimeters here in the height of this inner door frame, I figured out then what the size of the piece of the laser safety material would need to be. And that leaves us, so here's the whole piece here. I modeled that actual piece that I bought, and that leaves us with this chunk up here. And then I further took that and divided that into two pieces so that we can have a side window. Because one of the things that I learned from using this one, there is an autofocus on the machine and it works pretty well, but it's still really nice to be able to look from the side. There is, you can't see it here, but there is a mark on the side of the gantry for the focus height from the inner part of the machine down to whatever it is that you're engraving. And you can actually measure with a tape measure or with a ruler, the distance between that line that's drawn on the side of the gantry down to whatever you're engraving on to confirm that you are absolutely on the right focal plane before engraving. You can't see that here because you really have to look from the side, and there's no way to get your head in there to see it. Like it's completely impractical. If you ever need to use that mark to line up your engraving, you have to actually take the enclosure off. With this one, if I position another window here, we should actually be able to look in from the side of the machine, you know, sort of open the door, you know, hold a ruler in there with our hand, and then look through the window on the side, line it up with that red line on the side of the gantry. And then I still had a piece left over, even with as big as it seemed practical to make that window. So I thought, you know, I'd get a little cute, maybe have a little FPF logo on there. I thought that'd look kind of neat while the machine's running. You'd see the light of the laser flashing behind my logo here. One thing I'm just realizing I didn't bother designing yet is how I'm going to retain that piece of laser safety material in here. So I still have to do that. And there's already a lot of parts here to print. Here, let me unhide the rest of my design space. So you can see we have the upper and lower portions of the outer door frame, the inner part of the door frame. This is 3 different pieces. The pass-through for the exhaust is 2 pieces. We need to print 2 of these. So that leaves us with the challenge of how are we going to cut these side panels? Because I have the design, like I know exactly what these need to look like. And on the original enclosure, these were coroplast, and that stuff is super easy to cut. If you pop a fresh blade in your utility knife, that stuff cuts like butter. I'd have no concerns about, even for our interior cuts here, just marking that all out with a straight edge and a marker, and then coming back with another straight edge and the utility knife and cutting all these out. And in fact, that's how we did the coroplast panels for the last enclosure. And all of our external cuts and our internal cuts were plenty good enough that when we popped our 3D printed parts in, it covered up any little bit of sin in the corners. But we're not going to use coroplast for this. What I'd like to use is either that corrugated core material that has a thin aluminum skin on both sides, or the solid core lightweight stuff with the aluminum skin on either side. Now, I've never worked with that stuff before, but I don't think that's going to be anywhere near as easy to cut A CNC router would probably do it, but I don't have a CNC router, or well, I guess I technically do, but not one that would cut panels anywhere near this size. Now, as dramatically concerned as I just sounded about this, I actually know exactly how we're going to solve this, and I'm pretty excited about it. So when I went looking for a distributor to order a couple sheets of this ACM panel from, or the aluminum composite material, which is this sandwich of aluminum and polyethylene, a familiar logo came up in my search. Longtime subscribers to the channel might recall back when I shared the design for this GPS mount that I had come up with to hold a Garmin GPS right at the handlebars on my Honda motorcycle. And before I had even shared this on the channel, I shared this on a couple of different motorcycling forums, and people reached out and asked, hey, can I buy one for my bike? And after like the third one of these that I sold, I realized how much I hated making these aluminum pieces. It's not bad when you're prototyping something, but when you're making it for like the third or the fourth time, and it's a lot of handwork and file work to get the details just right, and the position of these bores needs to be spot on for this to actually line up on the bike, I realized there had to be a better way. So I discovered Send to Cut Send, and I actually had a whole bag of these made for, I think, like 20 bucks or something. Now, this is a couple of years ago. I'm not sure if the price would be the same today, but I remember being blown away with just how cheap it was to get like a dozen of these guys versus, I think, the hour and a half it was taking me to make a set by hand. And when I saw their logo come up in the search results and realized that not only did they have this elusive ACM panel, but they would also cut it exactly how I wanted it, I reached out. And I explained to them what it is that we are designing here on the channel and where the panels would fit into the overall design. And I asked if they would potentially be interested in supplying the panels for this project. And they said yes. So what I thought was going to be the hardest part of this project, I think just turned into the easiest. And when I say the easiest, I genuinely mean the easiest. All I had to do was just export these flat faces as DXFs. And then I came back over to the Send Cut Send website. I uploaded all of those DXFs, picked the material that I wanted the stuff cut out of, and added it to cart. And that was pretty much it. Here, we'll actually do one over again. Go with well, this is the logo. Should be the same as this down here. Yep, drawing units are millimeters. You pick your material, and there is a ton of stuff in here. I didn't even look through everything because I already pretty much knew I wanted to work with that ACM panel, but we could have had them done in titanium. That would probably still be heavier than the composite material, though I don't know, not sure. So let's see, I went in composites. Ooh, carbon fiber, nope, ACM panel. And they've got it in black and white brush finish. I think the brush finish would probably look the best, but I fear it would also be a fingerprint magnet, so I ultimately chose the black. And they carry it in the 3mm and 6mm. I went with the 6mm because that is the same width of the internal rails on that 2020 extrusion. I guess 3mm would be lighter, and I bet you the thickness of the aluminum skin is probably the same, but then we would have had to come up with spacers or something. It's just convenient to go with the 6mm size. It gives you the price as you're choosing options, so you can see what it's actually going to cost you right away. And then they've got a bunch of additional services they'll do as well. Like you can upload design for bending if you want the part bent, countersinking, dimple forming, hardware insertion, tapping, and then they do finishing as well. But all of the edges of our parts, I guess aside from this logo, now that I think about it, but all of the other edges, all the other cut edges are going to be covered either with the 2020 rail or 3D printed parts inserted into those panels. So I didn't choose any finishing options. I just added each piece to the cart and checked out. And that's it. So with these parts now ordered and already on their way to me, like I said, what I thought was going to be one of the hardest parts of this build turned out to be the easiest. I kind of feel like I cheated. Is this cheating? Did I just cheat? I don't know. Comment below. Are you allowed to do this? If you've got a project that you're working on and there's a part of it that you're just not sure how you're going to do, or maybe you do know exactly how you're going to do it and you're dreading that part, I'll put a link down in the description. Check these guys out. I don't get anything if you click that link, but they will know that you clicked the link from this video, and that'll probably help us out in the future if we want to get some more parts from them. And don't tell them I said this, but even if they said no, I was still going to order the parts from these guys because I've worked with them before and I really didn't want to figure out how to cut these pieces. Check them out. They're pretty great. Well guys, there are a lot of parts here that I need to 3D print. So I better get started on that, or they're not going to be done before this time next week. And some of these I think are going to be pretty tricky. A lot of these are pretty easy prints, but particularly the upper and lower door frame parts, I remember how challenging they were to get those printed cleanly last time I did this. Now, the Soval SV08 Max is a much nicer machine in every way than the Neptune 4 Max that I printed the last ones with. But I'm probably still going to go through at least 2 different iterations of support settings until I'm happy with this, because we're really going to have to print this with this face here down on the bed, which leaves this whole area supported, and then those bore holes up here to secure these in place. And maybe I'll design a template to pre-drill those holes that fits in, and that we can just slip a drill bit in for that front panel. Because I really want everything to be nice and clean on the front face of these. Like this has that bevel, and then a recess section here. We have the bores that the magnets press into, and that geometry has to be pretty accurate for the door to swing in here. So we really need that to be sort of the top surface. I guess we could print them standing up, but that would be pretty crazy, and we wouldn't have strength in the right direction for those parts. So, I mean, I'm sure I'll get them done. But point is, I better get started on that because I doubt they're going to work on the first go. So guys, I hope you enjoyed this week's video, and I hope you'll come back next week to see me try and put all this together, because I pretty much guarantee that I did not get everything right on the first try. I really hope I have everything right on these panels, because I'm not going to be able to duplicate those again without reordering those parts and waiting for them again. And I think it's already going to take the better part of the week for those parts to get here. They had a faster option of like 2-day shipping, like if you're in a rush for parts, but the standard turnaround, we'll get them here in plenty of time for next week's video. And special shout out and thanks to my patrons that support the content on this channel. I will put a link down in the description of this video to the Patreon if you want to check that out. We've got a pretty active community of folks over there and on Discord as well. And if this is by chance your first time here on the channel, this is all we do. It's all functional 3D printing and the design and engineering and other associated processes and tools to go along with just generally making with 3D printing. So if you enjoy that sort of thing, check out some of the other videos on the channel. And if you like what you see, hit that subscribe button. And guys, if you do, I'll see you next Friday.